All right, so let's carry on with this problem. So we did the prep work in the previous video clip, so now we can just walk right through our 4 steps. Step 1, the alternate hypothesis is the treated population mean of difference scores will not equal 0. The null hypothesis is the treated population mean of difference scores will equal 0. Again, for a two-tailed test, that's the only thing we can write. So make sure those D subscripts, again, are required on this step. You have to put them there. You could omit them anywhere else and it wouldn't really be much of a problem. But here, it is actually an error in your statement if you don't have it there. Step 2, I'll just put over here. Well, it's a two-tailed test. The alpha level that we're going to work on is 0.05. And this study has 5 degrees of freedom. Remember, there's 6 participants in it, or there are 6 different scores in it. 6 minus 1, 5. So again, go down to the heading for two tails, go over to the alpha level 0.05, go down to the degrees of freedom of 5. Of course, that will be there exactly. And when you do that, you will find that we have a critical T of positive or negative, what is it, 2.571. So our critical T, 2.571 plus or minus both tails. All right, there's our first 2 steps in. Let's begin our calculations for step 3. So as always, 3 things to calculate. First thing we have to calculate is the sample variance of different scores, which is the sums of squares for different scores divided by our degrees of freedom for our different scores. We did in our prep work the sums of squares and got an answer of 30. Our degrees of freedom is 5. So 30 divided by 5, we end up with a sample variance of 6 points. Second, estimated standard error is the variance of different scores divided by the number of different scores, square rooted. Well, our variance of different scores is 6. The number of scores in the sample of different scores is 6. 6 divided by 6 is 1, square root of 1 is 1. So we end up with a value of 1 for error. And then last thing, our T statistic. So remember, all we need here is the mean of different scores from the sample divided by error. Again, I just want to point out, this is built the same way. I pointed out for the other chapters, so I should point it out here. The top says, what differences do I actually observe in my data? And the bottom says, yeah, but how much of that is random chance, right? So the mean of our different scores we calculated in the prep work was 3. Our error is 1, so our T statistic is 3.00. Remember, if it's a statistic value, we have to put the 0.00 behind it, even if it's a whole number. So we look at that compared to the little roadmap we made in step 2. Back in step 2, our critical T was plus or minus 2.571. We're all the way out to 3, so we are for sure in the tails. So for step 4, we are going to reject the null hypothesis, because we have landed in the shaded areas in the critical regions. And if we were asked to write that in APA, we would say that we had a Okay, we would say we had a T of, remember our degrees of freedom here is 5. Our T statistic was 3. And there it is. There is a completed repeated measures t-test with all of the scratch work included in it, so you can see how to work it all the way from the very, very beginning. Remember, you've heard me say now, I don't know how many times, the problems will always give you enough information. You just have to figure out how to combine it to get what you need. So if it gives you a standard deviation, which it shouldn't be giving you much anymore, but it will once in a while, well, we know we've got to square that to make it variance, that sort of a thing. That's the two-tailed example. So in the next video part, we will look at this as a one-tailed example like we always do.